Hello, Algebra 2 class. Today we're going to try a lesson here with some more technology, so hopefully this might be a good one. Hope you can read the board. That's my number one concern, but not too much glare. But today our lesson is going to be about regression. Okay? And regression is the statistical analysis of how two variables are related to each other. So what link do we have between that? And in mathematicians, we look for a way we can talk about correlation. That's a term that's very much similar to regression. Correlation is the strength and the direction of that connection between the two variables. We want not only do we want the direction, but we want strengths. We want to say more, okay? I would say than regression. So the first thing is I have three graphs up here, and this graph here shows, you can see the black x's, and as we look at the black x's, I can see that as the x's are getting larger, the y values are also getting larger, okay? And also I like to think of it as, if I were to draw a line that represents this data, do I have a good place to draw the line? Am I sure where it should go? And as I look at this, I have a pretty good idea that the best line, or the line that fits it pretty well, would be a line somewhere in the middle, okay? And I'm not sure, that might be too light. I'm going to try a different color here. Somewhere here in the middle, that'd be a pretty good line right there. This next set of data over here is kind of scattered about, and there's some up here, and there's some down here, and there's down in this corner, and there's up in that corner. And it's very hard to get a good idea of where I should put a line to represent this. You know, one line to represent all this data. And that's the key. We have this information of things that we've observed, and we're trying to mathematically come up with, here's the best one. And so for here, I'm not really sure where it would go. It might go here. Some would say that's a pretty good line. Some might say, oh, but that's a good line. And others would cut it right in half, and we have so many above and so many below. And that's the idea of one line that's the best line, is you're trying to get something that line is for sure the best one. And over here, if we take a look at the blue ones, we can see as the x values are low, the y values are pretty high. And as the x values get larger, the y values come down. And this one has a pretty easy idea that the line should be somewhere right there. It's a good idea that that's where the line is. And without much problems, we're saying, yep, that's where I should put it. So this gives you an idea of three different correlations. Now, we tie a number to that, because as mathematicians, we want to say, well, here's the number that goes with it. And it makes sense. This line is going up, so it has a positive slope. So we're going to tie in our ideas of slope. And, okay, so we're going to tie in ideas of slope. We think that this m value here is positive, okay? And this r value is going to be towards positive 1. I would guess this one to be about 0.8, okay? And an r value is a correlation coefficient. So that's the number that we tie to the correlation. This r value is going to be about 0. Because we don't know if it's going up or down. We can't predict. If I tell you what the x value is, you don't have a good prediction of what the y value will be. So that r value is going to be close to 0. Whereas this r value, notice the slope is negative. Okay, this r value is going to be negative 0.95, let's say. It's going to be definitely better than this. You know what? I'm going to go back and switch this to 0.75. And I'm going to say that r value is negative 0.95. Now, that does not mean that the slope of the line is negative 1. This just means that this has a good fit. In general, our correlation coefficients range from negative 1 up to 1. Okay? So the numbers we're going to get for r are always going to be between negative 1 and 1. Positive 1 would be a positive perfect correlation, meaning that all of the points are on the line and the line is going up. So another example of that would be that if I have data that is just barely creeping up, however, all of those data points are on the same line, that would be an r value of 1. Okay? Likewise, if I have a bunch more data and all of these data points are going down, even if it's a steep line. Let's say we have a very steep line here, but all of those points are on that line. Yeah, don't give me a hard time. It's not a great line, but all of those points are on that line. then this r value will be -1. So notice the slope of the line doesn't come into play for the r values. Just are all the points on there. That's correlation. But what we are going to do now is we are going to take a look at this and say, what if I were to find the equation of that line? What would that equation of the line be? So I need a little space here. And to do that, let's remember what we're going to do is we're going to take a look at a couple points. So we have this point is at 1,8, and we have this point, we'll call it right there, is at 10,2. So we have the point 1,8 and the point 10,2. Can you come up with an equation for that line? Well, we have, if you remember, the point slope formed per line. If not, let's go ahead and figure this out. We need to know what the slope is, and we need a point on the line. Okay? We have a point on the line. Pick either one. I'm going to choose 1,8. And x minus 1 goes there. And now I need to figure out what the slope of that line is. To figure out the slope, remember we're going to take the rise over the run, and we'll take that. I hope it didn't turn off. I knew my camera was shut down there for a second. So I'm going to go ahead and take the slope right here, and we're going to take this 8 value minus the other y value, 8 minus 2, over 1 minus 10. 8 minus 2 is 6. 1 minus 10 is -9. This is a -2/3. And so we'll put that slope in as -2/3. So that, if we do algebra, will give us the equation of that line. Say y minus 8 is -2/3 times x plus 2/3. And then I add 8, y equals -2/3 x. And 8 plus 2/3, that's going to be 24/3, is going to be 26/3. So there is the equation of that line. Now, in actuality, to find this line of best fit, your calculator is the best at doing this. Because what mathematicians would do is to find the line of best fit, they would take an average of all the x values and an average of all the y's and find a center point. Okay? And then they'll draw a line and check how far away vertically all of these dots are, and they'll call those residuals. And then they'll take those distances away and they'll add them up, and then they'll check which line has the lowest value there. And that would become their best line. What you'll need to do now is learn how to use your calculator to do this. And so I will provide directions on how to do this on your calculator, and now would be a good time to practice that on your calculator. So this is this lesson. You also work in some groups today, and you'll try to remember the difference between being a strong correlation and a positive correlation. Those are different things. A weak correlation and a negative correlation. So actually, of these three, the strongest correlation was this last one. Okay, but it was a negative correlation, so those are different. That's one of the things you're going to do in groups, and make sure you have that. Hope this provided some good instruction for you, and it wasn't too confusing.